to the classification of magnetic materials. So basically they are classified as, first of all, like we have magnetic materials, non-magnetic materials, right? So free space and air are coming under non-magnetic, and the chi-m is 0 for those non-magnetic materials, and in other way we can say it as relative permeability is 1, right? So otherwise, if these two conditions are not satisfied, we can say that material is magnetic. So in that magnetic we have dia, para and ferro. So out of these, the dia and para are linear and non-magnetic. Okay, and ferro is non-linear and magnetic, and it is below Curie temperature. So you check what is this Curie temperature is. Okay, and like if you put the values of magnetic susceptance and relative permeability as a summary here. So for magnetic materials, if we classify them as linear and non-linear, and linear as dia, para, and for dia the susceptibility is less than 0, and for para the chi-m is greater than 0. Okay, and relative permeability values are less than or equals to 1 for dia and greater than or equals to 1 for para. So from chi-m itself we can get this, because mu r is 1 plus chi-m, right. And coming to the non-linear, that is ferromagnetic materials, chi-m is very greater than 0, and so mu r will be greater than 1. Suppose if mu r is equals to 1 or approximately equals to 1 for most practical purposes, like mu r is almost 1 for most practical purposes in which we use magnetic materials. Okay, if we see the all theoretical points related to the dia, para, ferro in a comparative way, it will be like this. So in case of dia, where it is 0 permanent dipole moment is there, these are weakly affected by magnetic field. Okay, they are like mostly unaffected, that means weakly affected by magnetic field. Whereas para, which are having non-zero permanent dipole moment, magnetic fields produced by orbital and spinning electron do not cancel completely in case of para. Okay, and in case of ferro, which are having non-zero permanent dipole moment as para, and these are called ferro so because best known material is iron. These materials are known as ferromagnetic materials because iron is the well known material which is having the characteristics of these materials. Okay, and the examples of dia are bismuth, lead and copper. Okay, listen, copper is a diamagnetic material, and silicon, diamond, also sodium chloride, that is salt, NaCl. Okay, and the examples of para are air, platinum, tungsten, potassium. Okay, and the para is temperature dependent, unlike dia. Means diamagnetic materials are temperature independent, means their characteristics don't vary with temperature, whereas para is temperature dependent. Okay, and also examples of ferro are iron, cobalt, nickel and other alloys, right. Then for dia, superconductors exhibit perfect diamagnetism, like when or at a temperature near absolute zero. So superconductors exhibit diamagnetism at a temperature of absolute zero, that means 0 Kelvin. Okay, and chi-m is -1, mu r is 0 and b is also 0. Okay, And although the diamagnetic effect is overshadowed by other stronger effects, all materials exhibit diamagnetism. Okay, what is this? So, even though we have other stronger effects which may not make diamagnetic effects to a particular material, almost all materials exhibit diamagnetism. Okay, then coming to the para, their chi-m is in the order of 10 to the power minus 5, 10 to the power of minus 3, and all are positive only. Okay, and the applications are masers, right? So you search for these masers, what is meant by masers and all. Then coming to ferro, these are capable of being magnetized strongly. That means they will get magnetized in the magnetic fields heavily or strongly, and they retains considerable amount of magnetization when removed from field. So even if you remove that material from the field, they are going to have or going to retain considerable amount of magnetism. That is important. And if temperature is greater than Curie temperature, they are going to become linear para. Okay, in linear there are para and dia. So if the temperature is greater than Curie temperature, ferro is going to become para. This is very important from the point of view of theoretical bits. And non-linear, these ferro are non-linear, and B bar is mu naught mu or H bar,